Okay, vectors lesson. I'm going to tackle a couple of things in the vectors lesson. It might split into two depending on how long it takes. The first thing I'm going to talk about, I'm going to do the hiker question, but I'm going to do both versions, the components version and the trig laws version. Before I get into that though, quick point, the idea behind vectors, we already learned about the Fab Five, the five kinematics equations. They work when we're dealing with one dimension. And in one dimension, you deal with direction by calling it positive or negative, opposite directions. Vectors let us work in any number of dimensions. We can work in 3 dimensions, we can work in 12, it doesn't matter, as long as we know how to deal with the vectors. Now, in this course, we're going to stick to 2-dimensional vectors. We're going to talk about north, south, east, west, up, down, left, right, that sort of thing. So keep that in mind. The usefulness of vectors is when we have a direction, we have to account for it when we're putting things together, when we're putting 2 different motion parts together. Now, some basics. When we're dealing with vectors, adding or subtracting them, for example, putting 2 displacements together to get a total displacement, we have to place them head to tail. So the way that would work on this, if we've got vector 1 and vector 2, and we want to know what they result in if we put them together, we take vector 2 and we place it head to tail with vector 1. Essentially what we're saying here is we do this and then we do this. What is the result? And the result, we start where we started and we finish where we finished, putting all the vectors together, so we get a resultant that looks like that across the 2. So that's how we add vectors together. Now, subtracting vectors works a little differently. Subtracting vectors we will get into when we talk about vector acceleration. It's the last lesson in the course. But if we wanted to subtract this vector here from this vector, oops, you see this vector, then what we have to do is we have to reverse this one. So we would take this vector and we would, I think this should work. I think we have to flip it twice. There we go. So this would be a negative version of the same vector. And if it's a negative version, we can add it to the other vector, and it's the same effect as subtracting it. We'll come back to that. Main point here, when you want to add vectors together, you place them head to tail, and the resultant is from the tail of the first vector to the head of the last vector. And the beautiful thing about this is we can take as many vectors as we want, and they will add together, and we can use this method to get the result. So, hiker question. Using that concept and using some other ones. Remember, for the component method, I'll also ask you to refer to the Khan Academy video. He gets into this in a little more detail in some aspects. But I'm going to solve this question using the component method. So, the question says that a hiker walks a certain distance, 35 degrees south of east, and then another distance, 65 degrees north of east. First step we're going to have here, first it's asking for her total displacement. So we have to remember this is what we're looking for. And the square brackets is where we're going to put the direction. We'll deal with that later. Let's draw the vectors. Second step in any question is to get the concept, draw the picture. So here's the concept. She goes 25.5 kilometers, 35 degrees south of east, which means she goes from east, 35 degrees south, and walks 25 kilometers. Now, you should draw the vectors roughly to scale. You don't have to have them perfectly to scale because the math will take care of your answer. But drawing them roughly to scale allows you to see how things should be turning out. So this is your 35 degrees, and this is your 25.5 kilometers. And then she goes 65 degrees north of east, which means east, 65 degrees north, and she goes 41 kilometers, so further. So I'm making the diagram roughly to scale. And this is going to be 65 degrees. And the resultant, when it's asking for her total displacement, it's saying from the origin, how far and in what direction is she after she's done both vectors. So this is the resultant vector. I'm going to switch to the next page. I have it done up in a little slightly nicer way. So, and I have the answer at the bottom right. If you want to pause right now and see if you can figure it out and get to the answer, great, awesome idea. Here's how we solve this using components. Every vector can be broken down into as many vectors as we want, as long as the first one has its tail at the start, and the last one has its head at the end, and they're all head to tail. So we could, if we wanted to, draw this vector by doing this vector, plus this vector, plus this vector, plus this vector, plus this vector. It's exactly the same thing, and if we could represent it that way, and it was useful to us, we would. Now, obviously, that just complicates this particular vector. But we can simplify this vector for the purpose of adding them together. If we have a vector like that, we can simplify it by breaking it into a horizontal component and a vertical component. These two blue vectors are the same thing as the green vector. The distance traveled would be different, but the displacement is the same. And this is a 90-degree angle, which means we can use Pythagoras to figure out the length of that vector. Or we can use trig ratios to figure out the lengths of these ones. So that's the component method in a nutshell. What we're going to do is we're going to break the first vector into its horizontal component and its vertical component. Now, its horizontal component is going to be 25.5 times the cosine of 35 degrees. Because this angle here, 35 degrees, the horizontal component right here is the adjacent side to that angle to which the main vector is the hypotenuse. So adjacent over hypotenuse allows us to solve to get this value, 25 cos 35. So our x value for that vector is 25.5 cos 35. Our y value for that vector is going to be 25.5 sine 35. Now the second vector, I'll do this in red because I'm running over top of other things. The second vector starts here, and its horizontal component goes to there. So this, again, is the adjacent to that angle. So it's going to be 41, let's call this x2, 41.0 cos 65. And the vertical component is going to be 41.0 sine of 65. So now what we're going to do is we're going to take the horizontal components, put them together to make one big horizontal component, put the vertical components together to make one big vertical component, and visually we're going to get 1, 2, 3, and 4. Sorry, let's put that in the right order. 1, 2, 3, and 4 to give us the same resultant, and that's going to give us a right-angled triangle. It looks like this. The two x components together give you that vector. The two y components give you that vector. They're at 90 degrees, and the resultant is the hypotenuse. So, adding the x components together, x over the resultant x is going to be 25.5 cos 35 plus 41.0 cos 65. Our y, the y component of the resultant vector, is going to be 25.5 sine 35 plus 41.0 sine 65. And because it's a right angled triangle, the resultant squared, we just use Pythagoras to get Rx squared plus Ry squared. We plug those values in, we should get 44 when it's rounded. Now to get the angle, we have a different situation. We have a horizontal and a vertical, and we have our hypotenuse. We need this angle here. But we know this is Ry and this is Rx. We know that the tangent of that angle is going to be Ry divided by Rx, or opposite over adjacent. So using this method, we can solve for the angle. And the angle should come out to about 31 degrees. And since we know that the resultant is going from east towards north, 31 degrees, we write it like this: east 31 degrees north. And that is the component method for solving this triangle. Did I even record that? I did. Good. So that is the component method solved. Fill in the numbers yourself and make sure that you can get these values. Something I need to point out, I did have something wrong in the Ry. Pause it now and see if you can figure it out. The problem is right here. I gave the first Ry, I gave this component here a positive value when I had identified north as positive, and it's going south. So that should have been negative 25.5 sine 35. Okay, so I'm going to leave it here. I've done the trigonometric method in class, and I can do it again, or I'll make a video tomorrow if everyone prefers a video. Good luck. Practice on that vectors example sheet I gave you. We'll see you in the morning.